In this example, we've been told that the cosine of theta is equal to the square root of 2 over 2 and that sine is negative. And we want to find the other, all the other trig functions. Well, meaning we want to know, okay, we know cosine, we want to know sine, we want to know tangent, and their reciprocals, meaning secant, cosecant, and cotangent. Okay. Now, one thing I just want to mention real quick is that if cosine is positive and sine is negative, recall that cosine measures x values, right? The adjacent side of a triangle, so x values. Sine measures the opposite side of a triangle, so y values. So we're looking for where x is positive and y is negative. That occurs in the fourth quadrant. And you can kind of, you maybe can piece some things together from that. You don't necessarily have to, but it's just worth thinking about. So cosine is the square root of 2 over 2. The reciprocal of that, of course, is just 2 over the square root of 2. If you rationalize that, you just get the square root of 2. Okay? Clean that up a little bit. Next, the sine. Well, let me just draw the triangle real quick as it would appear in that quadrant. Of course, we know the adjacent is square root of 2. We know the hypotenuse is 2 because we know the cosine. If we use Pythagorean theorem, we could solve for this side. It's also the square root of 2. So that means that sine, remember it's negative, is negative square root of 2 over 2, which makes cosecant. And again, we could go through the process of writing this down as the reciprocal or rationalizing, but since they're the same, just with an opposite sign, if secant is square root of 2, cosecant must be negative square root of 2. And finally, looking at tangent, recall that tangent is the adjacent, or opposite over adjacent. Well, the opposite and adjacent are the same, meaning that tangent has to be 1. But remember also that tangent can be defined as the sine of theta over the cosine of theta. And since sine is negative, negative divided by positive is negative. That makes tangent negative 1. And of course, cotangent is also negative 1. Real quick, we're talking about graphing again. In this example, the amplitude is 4. It's the coefficient of the trig function. The period is 2 pi over the coefficient of x, so that's 3. Our vertical shift is up 2 units, just whatever's added or subtracted at the end. And our phase shift, or horizontal shift, is to the left pi units. So we start at pi. Okay, that's where we're going to start. We can put in our vertical shift that we're going to be up to. With an amplitude of 4, we're going to go up to 6, and down to negative 2. One thing I always like to kind of figure out is, okay, well, if it starts at pi, if that's our negative pi, where's it going to end up? So if I add 2 pi over 3, I'm going to get negative pi over 3. So I can mark that in. That's where this thing's going to end. Is that, let me see if I can't maybe space this out a little better. Negative pi over 3 right here. Since it's sine, it's going to start in the middle. So it's going to start right here. It's also going to end up back here. It's going to go all the way up. All the way. Missed it. All the way up, all the way down, and back. And then we'll just continue like that, on and on. Next, I want to talk about when tangent, what angle we'd plug in to make for x to make tangent equal to 1? Well, maybe there are a lot of ways to do this. You could certainly use your calculator. You could use inverse tangent, the inverse tangent of 1. You could know the fact that, here's another way to do it, that sine over cosine is the same as tangent. So if sine over cosine is 1, then sine must be equal to cosine. That occurs at pi over 4 or 45 degrees. So we'd write that. We'd say, okay, it's going to be pi over 4. Unfortunately, that's not the whole answer, because we're talking about a periodic function, a function that repeats itself from negative infinity all the way to infinity. So, if you think about what tangent looks like, and then it repeats, and going back the other way, it does the same thing. Excuse my poor drawing, but that's basically it. So if I put in, when is it 1, there are an infinite number of times that it's equal to 1. Well, now we got to call on what we know about tangent, the fact that its period is pi. So every pi units, we're going to have another time the tangent is equal to 1. So how we denote this is we say it's pi over 4 plus pi multiplied by k, where k is an integer. And the reason that works is because integers are whole numbers and they're opposites. So we take care of the fact that, if here's tangent, we can also work backwards to the left, because it's periodic, it's repeating in both directions. So the fact that this could be a negative number takes care of the fact we could also be subtracting a pi. And of course, being an integer, it has to be a whole value of pi. We're repeating every pi, so it's pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, 17 pi over 4, and so on. It's not random values in between. These are the values that it's actually going to be 1. Finally, I wanted to talk a little bit about a graph. And if you notice the small difference in this, really the only difference is the fact that the 3 here has been multiplied into the parentheses. Usually we see a parentheses right in here. In this case we don't. It doesn't change much, but it changes a little. Let's start with the amplitude. It's still 5. The period, still 2 pi over that coefficient of x, so 3. Vertical shift, still down 2. So I mean, we haven't changed anything so far. We still got the amplitude in the same way, right? We still got that from here. We still got the period the same way, 2 pi over this value. We still got the vertical shift the same way. So you might think to yourself, well then how is it really any different? Well, what we have to do is we have to factor out that coefficient. Okay? We cannot have multiplied that into parentheses. We need to find the phase shift. We need the parentheses to be here. So if I factor a 3 out of this, of course I just get x. If I factor a 3 or divide a 3 out of this, I get plus pi over 3. So my phase shift is left pi over 3. So if I sketch this real quick, I've got a vertical shift, I'm down 2. Amplitude's 5, so it goes up to 3, down to negative 7. We start at negative pi over 3. And again, I always like to know where it ends up. So if I say, well, it started at negative pi over 3, and one period is 2 pi over 3, where do I end up? The answer is positive pi over 3. So I could maybe mark that over here. Now it's sine, so it starts in the middle, starts right here. To do that, to maybe give me some benchmarks, we're going to go up, back down, back up, and then we'll continue on from there.